Okay, friends and neighbors, we are going to do another networking video, this time on network address translation and the network time protocol. Now, this is going to be a build, so I'm not going to go through all of network address translation. In fact, the only reason that it's part of this video is not because it has anything to do with NTP, but rather because we're solving a problem in the lab, and when you're port poor, sometimes it's really handy to build a NAT configuration so that you can do whatever you want on the network behind it. And so that's what we're going to do first, and then we'll talk a little bit about network time protocol and see how to get a router to understand that there are network time servers out there and to update its date and time. So here is a small routed topology. And so what I think I'll do is we will add some details to this. Let's pretend that this is the RIT network. Okay, so that's 129.21/16, and then I'm going to create a network in the middle here, 172.16.00/16. So this is a private network, and then I'm going to do another one over here. And the whole point of this is to show us that we can run a couple of NAT boxes behind each other, and we'll do it like this. So I've got, and the goal here is to set up NAT on both of these, right? And we'll do that here in a second. To set up NAT on both of these and get these two PCs to talk to each other. So what I'm going to do is we'll make this one 192.168.1.1, and over here this will be 129.21.01, just to make life easy. All right, so let's do that. Okay, 0.1, that'll be fine. And then let's also, well, I guess we'll also do its gateway. And again, we'll just keep it simple. Okay, so that sort of dictates what I have to do on this particular router. And we'll keep in mind these two networks. Always say no to that. And so just so we remember who we're talking to, so we're going to say host name R1, and then we'll say int f0/1, and we'll give it its IP address. And no shut, and this will tell me that this is on this side. So this also tells me that this is f0/1, and yeah, I'm using the fast Ethernet interfaces, but who cares? And now we'll set up the middle network there. Now, if you are thinking ahead a little bit, you might be saying, well, I'm going to worry about routing. And in this topology, even though we have 3 networks, we're not going to worry about routing statements at all, because we're going to be doing network address translation. And I'll show you how that works here in just a minute. So this interface is the, on that side. So we'll make it, let's see, normally I do this like that, 253 maybe. Oops. 00, and we'll say no shut. Now, here's how I'm going to solve some of my problems. I could do another static interface over here because I know the whole thing. But let's say that this router is not willing to give a static, or let's say this router doesn't want to deal with static addresses downstream. Or you're not sure what static addresses are available to you. So what we're going to do is I'm going to create a pool. Just as if, and we'll just call it production, just as if I might do if I was running a regular router. And this is what allows us to set up a network address translation box anywhere. And so what we're going to do is say, well, this is the network that we're doing here is 172.16.00. Right, and then we might say our default router for this one is 172 like this. Now that's all that I'm going to do for right now. But I do want to also remember to do DHCP excluded address, the one that I just assigned to my router. Okay. So if we do a quick review of our configuration, we see that we've got this very quick, simple, and easy DHCP pool. And I've given my router interfaces some IP addresses. And then I can take a look at my routing table, and I can see that I've got two directly connected networks, but one of them is not up yet because the other router's interface is not up. Now, if I had put a switch in here, okay, then that would have solved that problem. But and I'll show you what I mean here in a second. Now, here's how I'm going to solve that particular problem that I was alluding to earlier, which is how we set up a NAT box anywhere. So first up, we're going to say, we're going to give ourselves a host name here. So we know when we're pulling up CLIs, we know which one we're talking to. And then I'm going to go to int f0/1, and we'll say no shut. Now the minute I do that, we go back over here, and if I take a look at my routing table again, we can see that my routing table is expanded to include this one because now the link is up. So that's a little troubleshooting tip, dead giveaway. If you are if you're experiencing problems with connectivity, take a look at your routing table, and if you don't have entries, it might be because your links are down. Now the other thing that I'm going to do here is I'm going to say IP address DHCP. Whoops, DHCP. And what that does, it makes this guy a DHCP client. And there's the address that just popped up right there. So now we could look at that also, but this makes this .1 on this side and .253 over here. By the way, this is also f0/1 and f0/0. Okay. Now, if I want to set up NAT, right, on a standard configuration, then what I'm going to do is, now I'm going to think ahead here a little bit, and I'm going to realize that if I set up NAT right here, and I set up NAT right here, then all of the traffic from this internal network will look like it came from f0/1. So the NAT statements that I usually like to build are with access lists. And so I'm going to build an access list based ACL or NAT configuration that only translates stuff from right here. And that's all that I'll really need. So I'm going to say, let's go to interface f0/0, and we'll say IP NAT inside. And then I'm going to go to f0/1, and I'm going to say IP NAT outside, and this just defines my two sides. Oops, spelling counts. And now what I'm going to do is I'm going to say access list 100 permit 172.16.00.00255.255. Remembering that access lists use wildcard masks. Oops. What did I forget here? No. Permit. What do we do here? Oh, yeah, okay. Yeah, IP 172.16.00. We're dealing with an extended access list. Oops. Now we'll do IP any. We'll do like that. Oh, come on. There we go. Took me a second there. All right, so that's my access list. Now, I could have done it with a standard one, right? I could also have said, and my life would have been easier if I'd have said something like this, IP access list 1 permit 172.16.00.00255.255. Then life is real easy, but for some unknown reason, I decided to use an extended, which has extra fields. Okay, so that explains that. Now, this access list and this one for that matter, are not doing anything until I apply them. And when we apply them in network address translation, it's not really a security thing. Network address translation, when you apply an access list that permits things, all that you're saying is, I want to translate these addresses. The rest of them, I'm not going to translate, I'll just route them. So what are we going to do? Well, I need to set up a translation statement that says, I want to take stuff that comes in on this interface, translate it to make it look like it came from this interface. So I'm going to say IPNAT source list. Okay. Well, let's explain the whole thing, right? So IPNAT is the statement, and actually what I want to do is say I'm going to do an inside. Well, what am I going to do? I'm going to take an inside source of some kind. Well, my source is going to be a list. Let's see, we got a couple options here. Now I could do static, but I'm not going to do that. I've already set up my access list, so I'm going to do, whoops, source list. Well, what source list? Well, the source list that I'm going to use, since it took me so long to build it, was 100. Now what am I going to do? Well, I'm going to specify an interface that I want to use to be the address that everything looks like it came from. So, or from which everything comes. And so that would be the outside interface, which would be F0/1. Now another keyword here is overload, and that means that I'm going to use one address for everybody. There we go. Now let's see if this works. What I'm going to do is I'm going to ping from this router interface. Okay, so I'm going to ping. Now, let's before we do that, let's actually take a look at my routing table. And we can see that I've got a default route that I picked up. So that tells me that I should be able to get out. So now what I'm going to do is ping 129.21.0.1. So we just want to see if this works. All right, so it'll take a second because we've got ARP stuff to get through. There we go. So that was, the first ARP timeout, or the first ICMP times out, because we have to ARP here. We have to ARP here. Nobody's talked to each other. But clearly it works. Okay. There we go. So now what does that look like? Are we really translating? So let's try that again. And we can see the packets going across here, right? It starts to go. Now, if I look at this packet right there, I can see that it is from, 172.16.0.1 to this address over here. And we keep it going. And now we're on the outside. So now what does it look like? Now all of a sudden we are, both of them are on the 129.21 address. So clearly our network address translation is working. PC1 here believes that it's communicating with this interface, but the translation occurs right here. Well, what does that look like? Well, we can take a look at the translation table. And there they are. And so these are all the addresses that started off, right? So this is the conversation that started off, and this is what the conversation got translated to. So this node was talking to this address on the outside, but this is the address that we use for the translation. And of course the destination stays the same. There we go. All right, well, we're part of the way through. So let's start to work on this particular PC now. And we know that we want this to be this address and its default gateway. We'll make life easy again. There we go. Okay, so that's that one. So let's finish this part of the router config. And we'll say we might have 0/0. And this will be there we go. And we'll say no shut. Oops. And that'll bring that up. Now we're doing spanning tree discovery right here, so that one will be just delay it a little bit. Now, will this work? Will this work going all the way out here? Well, it might, but it won't be translated. Why? Because the access list over here says I'm going to translate anybody from this network, but of course this is coming from the 192.168.1.0 network, so it's a little unclear as to how that would work. Plus, this router I haven't done any NAT with, so let's see what happens. Now that that's up and running, we'll open up a command prompt and we'll say ping 129.21.01 like that. Now it's attempting to go. Now we got maybe some ARPs going on here, but let's think about this for a sec. This PC has a default gateway, which is over here. This router says, okay, where are you going? And this router really has no idea how to get to the 129 network. It has a default gateway, okay, but this router has no idea where the 192 network is. So while the traffic might get out there, and we can see if that's the case, let's do it this way. While the traffic might get out there, the question is whether or not it can get back. And that's always the question with routing. So we'll just keep this going. So it looks like it gets all the way there. And by the way, was it translated? Well, it was not translated. All right, so that's a problem for our routing. So now it tries to go back, and this PC has a default gateway right there. And what does the default gateway says? Oh no! And this is going to be an ICMP destination unreachable. Right there. Message type 3 is destination unreachable. Okay, so that is a very typical routing problem that we would get into, and so we're going to solve that by running network address translation. So I don't remember which interface, F0/0. So this should be the inside. So I'm going to do IP NAT inside. And we'll do IP NAT outside. Okay. Now let's do a simple access list. IP access list, I don't know, 6 permit 192.168.1.0. There we go. Oops. access list. There we go. Okay, so let's do a quick review. Where are we at this point? Well, there's my access list. Oops. And we've got an IP address on F0/0, and we're a DHCP client on the outside. And I need to finish my NAT statement. So there's our inside, there's our outside. So this one is NAT. This one is NAT. But the key here is that this router is never going to have to understand that this network is here. So let's finish that. So we're going to say IP NAT inside source. Well, I'm going to do another list. And my list is 6 here. And what am I going to do next? Well, I'm going to overload again on F0/1. So F0/1 like that. Okay. Well, let's take a quick look again at my routing table. And so now the big question is, will this succeed? And let's try it, see what happens. There it goes. All right, well, why did it succeed? Well, let's look at our simulation. we'll step through it. The key is on the outside. We now look like we are both on the 129.21 network. So this transmission works on the way out. Now this PC believes it's communicating here. And the fun part about it is that we have a NAT box behind a NAT box. So this router believes it's communicating with this other router when really it's communicating with this PC here. Okay. And the last thing that we'll take a look at is the translation table here. There they are. And you can see who we were communicating with, right? The original communication was really between these two nodes, but then it's translated here. But we know that this address is translated again right here to make it look like it's 129.21.0.254. Okay, so again, why would you do that? Well, if for any reason I want to set up an experimental network back here, oh, I don't know, like I've got my own DHCP, my own DNS, and I want to worry about what my, see if I can test a configuration or anything like that, but I don't want to bother the rest of the production network. I could easily set up a NAT box, make it a DHCP client, and then I can fool around with whatever I want. Well, there you have it. Okay, so that's the NAT part of this. So now the question is, if I was building a VoIP topology or DNS or DHCP and I wanted accurate timing and I was getting that from my router, how would I do that? Now you can set servers up to talk to network time servers. For those that don't know, the network time protocol is there so that you can talk to the world of network time servers or server pools that are out there and get an accurate indication of the current global time. And we'll see here in a second, there are thousands of network time servers out there trying to do just that for us. So just quickly, right, if you wanted to maintain accurate time synchronization between systems on a network, somebody has to keep track of the actual time. And then on top of that, if somebody out on the network says, oh, here's the time, that timestamp came to you from a packet that was subject to network time delays. And of course, that's a problem. What we want to do is have some kind of mechanism that tells us not only how what time it is, but how accurate this time might be. And so the network time protocol has a way to accomplish both of those. By the way, the little race cars are here because in networking or in communications or in processing, we have sometimes race conditions that indicate whether or not things are out of order. Well, the race condition is the issue of having things happen out of order or out of an order that we expect. And so certainly when we're dealing with, getting a timestamp over the network or maybe multiple timestamps over the network, what do we know is correct? So here is our network time RFC 5905, widely used to synchronize system clocks among a set of distributed time servers. Okay, so the network time servers talk to each other and they get their information from an authority of some kind, and then clients, whether it's actual PCs or other servers, get their time from the server. And so this illustration is saying, well, my client makes a request and that takes a certain amount of time. The server processes it, which takes a certain amount of time, and then sends a response back. Also takes a certain amount of time. So we're talking about significant issues here with delay when we get an answer. And so what we're also going to try and understand is what is that delay and how do we compensate for it. So all I want to do in this particular video, because it's not really an in-depth network time protocol video, is that we want to just get the idea down because we're going to update our router. So the network time protocol sends information from primary time servers. Now, everything is set sort of back to Greenwich Mean Time, which is the universal time that is sort of a reference time. And then we want to understand how far away we are, and we want to take time servers that are sort of close to us. So there's a measurement for that. Now you can go out to this particular website, ntp.org, and see a list of time servers. But what most folks do is they apply to or they make use of an NTP pool of servers. And then what we understand is the offset or skew that we have from that set of clocks or those servers. So if you go out there and you're trying to take a look at the list of servers or the list of pools, the project, when you point yourself at it, the project actually says, well, these are the servers that are reasonably close to you so that we can minimize that network delay. And here's an example down here at the bottom. So here are a couple of websites that have a lot of information about NTP. And so this is what I was talking about earlier. So this is the pool of servers that are out there. So this pool actually is a collection of servers that is round robin via DNS. And this is what you would point an actual server to or a router to get your network time protocol updates. Now, if we want to understand a little bit more about that, you can get an idea of distance or sort of quality of the information through this measurement called a stratum. And the stratum is best illustrated right here. What we want is a reasonably close stratum. The farther down the line you are in terms of stratum, the farther away you are from sort of the most accurate time that's out there. And so this diagram sort of shows, gives you a little indication how that works. So you can go to the pool.ntp.org, but you can also take a look at the actual servers that are part of this. Now you can, when you pick a particular server, as I said, it mentions or it tries to use a particular server that is close to you. And some folks like to actually specify the IP address of an actual server. And so if you go out to NIST, you can also take a look at those sites over there. So there's a lot of support for NTP out there, tremendous number of servers out there. There are some fun graphs. Let's take a peek. So this is a list of active servers at any one particular time. And you can pull up your area of the globe too. By the way, this website here, Time Tools, is a very nice introduction to the network time protocol if you're just getting started. If I have time, I'll do another video on it. But there we go. Now, when you are actually communicating with network time servers, the network time protocols start flowing right to you. So what you, and a very particular time, rate of time. And so they look like this when you actually capture them. You can see the port that we're talking about here. And you can see that on a fairly regular basis, based on the timestamp, these time packets come to you. And that's because we're trying to keep a regular update of the time. So a little detail about network time, right? UDP port 23. There is a polling time at the rate at which you want to ask your questions. And then the stratum indicates how far away you are from an authoritative source. And this is just another look at the stratum list. Usually, right, you're not going to see stratum 0. Stratum 0 is, if you're drawing the hierarchy, this would be considered stratum 0. But if you receive a packet with stratum 0 in it, there's a problem. And here we have a basic representation of an NTP packet I grabbed. And so this one happens to be version 3, version 4 is deployed to. Here's my polling interval. All right, it's just a number, but the number has a value, 128 seconds. So if you're doing network time packets, they don't come as a flood, they come periodically. And then we also know that this is stratum 2, which gives you an indication of where I was in the hierarchy when I was capturing this, just on a host device. And then all of these other timestamps, the delay, the dispersion, all of these timestamps down here are all an indication or all trying to provide details to give the most accurate representation of time. You know, how much processing is done on the server, how far away am I, and all those kinds of things to give you this updated. Now, in a perfect world, you get timestamps from multiple time servers. So if we take a look at our packet list again, this is what you would expect to see. Here are a couple of different time servers that I was listening to. Everybody's port 123, and then the timestamps or the delays, right? If I was to do this calculation, hey, it looks a lot like 128 seconds. Now on a router, how would this actually work? What do we do? Well, let's take a look at our Cisco configuration here, and then we'll we'll go by that. Now these routers, this is obviously in packet tracer, so I'm not going to connect to the real world, but we can do the commands just as we would do here. So let's take a look. So the first one that we saw was show clock. And we can see that this poor router thinks it's 1993. It's not even time to party yet. We're not even at 1999. All right, so what can we do to change that? Well, if we take a look at our list of commands, we could set the clock and tell it where it is. Okay. We could tell it whether or not we're going to do, whether or not you're going to adhere to, changing your clocks for in the spring or in the fall. And then we could set, the NTP server. So let's try a couple of those. What can we do with our clock? Well, we could do our time zone, right? And for where I'm in New York, right, that's usually -5. Let's see what our options are. And so I could do, EST, something of that sort, and then pick my time zone, something like that. Okay, so that's pretty much what I would do. And then I would say, if I want to do NTP, I would say NTP. Well, what can I do with NTP? Well, there's a couple of things. If I wanted to be a server or be part of the server pool, or I wanted to specify a server, I could do that. So if I wanted to tell my router where the server was or who it should pay attention to, I might do something like this. NTP server. Well, what do I do here? Well, this could be the IP address, or I could be doing, something via DNS, which is what I would do with the pool. Oops. And we can see that this particular version of the iOS doesn't want to play nicely. Plus, I haven't configured DNS on this particular router, so I can get away with specifying an NTP server. And I might get an NTP server list from one of the websites from the pool or from NIST. And what does show clock reveal now? Now, I'm not connected to the internet with this particular router. But I might just say, well, it says, well, this is where I am. That's all that I really was able to add at this point. And there we go. Well, that'll do it for this one. Thanks for watching. Thanks for listening. This was a real basic build of a NAT behind NAT. And again, the reason that you would do that is because you want to do some experimentation and you don't know what available IP addresses are out there, so you just do the DHCP thing. We also know that network time protocol is actually fairly critical anytime you're doing synchronization, which is of course what a lot of servers do. Anytime you have servers communicating with each other, or we need an indication of an accurate time, we've got network time protocol out there. There's a collection of network time servers that are available in the world, and we now know that there's this mystical magical measurement called a stratum, and that you can engage with a particular server or a collection of servers called a pool, and you'll get the most accurate representation of network time. And usually we do that by communicating with more than one server at a time. We also know that a router, you can ask the router what its clock is, you can set its time zone, and then you can also say, by the way, I want you to get your time from a network time server or a pool of servers. Well, again, thanks for watching, thanks for listening. This is networking, you can do this, and may your network time packets and your NATed transmissions always reach their destinations.